you have I and J, so you will represent this box as a I, this box as a J. Okay, so IJ, you need to consider another pattern like in that direction. Okay, so to consider like this, like this. Okay, how? Now for first you will start from 0 0. Now 0, do you have any pattern like this? 0 0, yes. 0 0 IJ diagonal pattern. 0 0 0 0, not this diagonal. Okay, this is the different angle. This is the angle that is 315-degree angle. You need to consider 315, because for this you need to consider this is the second angle, 225-degree, but the distance will be 1 minus 1, 1 minus 1 coordinate, C 1 minus 1. If you want to solve for C, that is co-occurrence matrix for 1 minus 1, you need to go through that pattern. Okay, now I'm considering 1 1 pattern, so C11. Okay, so I have the pattern like IJ, like this, in this direction, in this direction. Okay, now first you will solve for the 0 0. Yes, 0 0 once, twice, so you will write 0 0 2. Then you have 0 1. Do you have a 0 1? Do you have a 0 1? No, there is no pattern. Do you have the 0 2? Yes, I have a 0 2, like 1 and 2. 0 2 0 2. I 0, j is 2. I 0, j is 2. This is like this, so I will write 2. Now you have 1 0, 1 0 1. Okay, you have 1 0 twice, so 1 0. And one more pattern. Do you find any more pattern? 1 0, 1 0, and 1 0. Yes, 1 0 1 0. So you have two pattern like this, 1 0 1 0. 2 1 1 1 1, only once. Okay, 1 1 in this direction only once, so you will write 1 1 2. You have 1 2 once only, this type of pattern once, so you will write 1. Now 2 0 2 0 2 0, you have no, so 0 2 1, you don't have any 2 1 or a pattern like this direction or a pattern. Then 2 2, yes, you have 2 2, the single pattern, so you will write one value. So in this manner you can actually find the co-occurrence matrix. You need to actually find the co-occurrence of J uh, regarding I. So you need to find a pair in that particular direction in distance. Okay, the repetition of IJ combination, the repetition of the distribution of IJ pattern. Okay, and you will be able to find the co-occurrence matrix. Okay, so this is nothing but this pattern you need to consider. So and this is at different angle. So theta defines the direction of a matrix from the central pixel. If you have NCMC as a central pixel, d is the distance from the central pixel, and d is the distance from the central pixel. Okay, now the gray level co-occurrence matrix is a square matrix. You need to consider the matrix should be a squared one. Okay, now there are two important variations and standard gray tone co-occurrence matrix. So there are two types of variation. First variation is you need to first normalize the co-occurrence matrix. Now how to normalize a co-occurrence matrix? So you will get the normalized version of a co-occurrence matrix, that you need to divide your co-occurrence matrix, means each and every pixel value divided by the total number of pixel values. Okay, so summation of pixel value, that is the total number of pixels, and you have to divide this input pixel by your total number of pixels, and you will get the normalized version of your co-occurrence matrix. So there are two important variations that you need to follow. First you need to normalize the co-occurrence matrix by this formula, and then you need to calculate the symmetry of the co-occurrence matrix. Now what is the symmetry? Symmetry is nothing but a symmetry of this ij pixel is equivalent to, you have a co-occurrence matrix. Okay, this is a co-occurrence matrix plus the transpose of co-occurrence matrix. Okay, you know the transpose of matrix. Okay, so the plain co-occurrence matrix plus transpose of co-occurrence matrix will give you the symmetric co-occurrence matrix. Okay, so normalization, why do we require normalization? It normalizes the co-occurrence value to lie between it. It will normalize to the 0 and 1 level. You will not go beyond the 1. But if you are calculating for the multiple values, you will have the values which will be in a range of 0 and 1, like 0, 1, 0 0.1, 2, 3, or 0.5 something, or 0.7, or up to 0.99. You cannot cross 1, because you are normalizing, because you are dividing your input pixel with the total number of pixels. You cannot go beyond 1. Okay, now why do we require a symmetric? So it groups a pair of symmetric adjacencies. Okay, this is the advantage. Okay, now we'll study the gray level co-occurrence matrix, GLCM. The method is same. That is, your co-occurrence matrix is defined by the summation. It will be 1 if you will be able to match the if you will be able to actually find the occurrence of J for I. If you find the pair ij pair in the image, you will write a 1, or the combination of 1. Okay, and if you don't find anything in the image, you will write a 0. Okay, so it is the c suffix dx plus dy ij dx and dy define the distance from your central pixel. We already studied that. Okay, we'll proceed with the example. Now suppose you want to find a gray level co-occurrence matrix for the input image like this. Okay, and if you get d is equal to 1 and theta is 0. Now what are the steps? Means we need to calculate number of occurrence of I pixel with j, okay, pixel at a given distance and angle. Okay, now they are giving only 0 degree. 0 degree, if you consider this pattern, 0 degree means only horizontal, ij. Okay, so you need to find the occurrence of I for the j, or you need to find the j occurrence for the I. How many times you will find the occurrence of this combination, horizontal combination, that is 0 degree and 0 1, distance 1, 0 1. Okay, so first, if you have the image, you will actually specify the ij values in this manner, j in this manner, 0 1 2 3, 0 1 2 3. Okay, so you have the coordinates like 0 0, 0 1, 0 2, 0 3, 1 0, 1 1, 1 2, 1 3, then 2 0, 2 1, 2 2, 2 3, similarly 3 0, 3 1, 3 2, 3 3. Okay, now you have a coordinates for each and every intensity value now. Okay, you need to start from the 0 0. You need to find the occurrence of 0 0. So you have 0 0 0 0 twice, you will write 2. Okay, okay, first you need to start from 0 0, 0 and 0. So 0 0, how many times you will find a 0 0 combination? 0 0 1, 0 0 2, 2 for 0 0 occurrence, so you will write 0 2 for 0 0. Now 0 1, how many times you will find 0 1 combination, like in that direction, 0 degree direction, at distance d is equal to 1, 1 2, you will write 2. Now 0 2, will you able to find 0 2, 0 2? Yes, once. 0 and 2, 0 is I, 2 is 2 is j. This is you will get once only, so 1. Now 0 3, do you have any 0 3 combination? No, so write 0. Okay, then next pattern 1 0, 1 0, there is no any pattern. 1 0, there is a pattern 1 0, but this is the different direction. This is a different direction. 10. You need 10 like this. 10 in 0 degree, not in 180 degree. Okay. This is 180 degree, opposite direction to the 0 degree. Okay. Then you have to find 1 1 combination. 1 1 1 1. Yes. Along the 0 degree, you have two combination. Two. Then 1 2. 1 2 1 2 1 2. You don't have any combination. For 1 3, you don't have any combination. For 2 0, you don't have any combination. For 2 1, you don't have any combination. For 2 2, three combinations are there in 0 degree. 2 2 1, 2 2 second, first, second, third. So you have three repetitions: I after J, I after J, I after J. Okay. So you have three combinations, and then 2 3, 2 3 2 3. Yes, you have only single combination of 2 3 in 0 degree. Okay, and then you have lastly 3 3 combination, that is a single combination, and you will be able to get the gray level co-occurrence matrix. Okay. Now the what is the next step? Next step was to normalize, and the another step will be after normalization you need to get the symmetric of your GLCM. So we will normalize now to normalize to actually okay. Okay, normalization is the last step. Okay, first you need to find a symmetric. First we will find a symmetric. So in you have the GLCM, that is gray level co-occurrence matrix. You need to find a transpose matrix. So if you arrange these column as a row, you will get a transpose. So 2210, if you write 2210 along the row, 2210. Okay, okay. 2210, you have the GLCM like this. If you write this row like by a column, you will get the transpose. Okay, you have already the transpose of your gray level co-occurrence matrix like this. I need to add. So GLCM and transpose of your GLCM will give you the symmetric GLCM. Okay, and after symmetric GLCM, you will go for normalization. That if you divide each pixel with a total sum of pixel 24. Now how many pixels? Now 4 plus 2 6 plus 1 7, 7 plus 2 9 plus 4 13 14 20 21 22 and 24. So total number of pixels are 24. You need to divide each and every pixel by 24. 4 divided by 24 will be 0.167. 2 divided by 24 will be 0.083. 1 divided by 24 will be 0.0416. 0 divided by 24 will be 0. 2 divided by 24 will be 0.83. Like this you will get the normalized GLCM. Okay, this is an example of 8 tone. You have 8 tones. Okay, and you need to actually find the combination for 1 1 up to 8 8. So you will find for the co-occurrence for 1 1 1 2 1 3 1 4 1 5 1 6, or if you're considering 5 5 1 5 2, and this, because you have up to 8 pixel value. Okay, okay, you have the extra box. Now the co-occurrence, after finding a co-occurrence matrix, we this is not that much usable. If you find only the co-occurrence matrix, you need to find the second order features. uh, you need to use that co-occurrence matrix in order to find a different kind of features like entropy, energy, contrast, homogeneity, correlation. So after finding a co-occurrence matrix, you will be able to find a different features. So by utilizing a different features or formulas, you will be able to process the image. Okay. So co-occurrence matrices capture properties of texture, but they are not directly useful for further analysis, such as comparing two textures. Instead of numeric features are computed. from the co-occurrence matrix that can be used to represent the texture more compactly. The following are standard features derivable from the normalized co-occurrence matrix. So by using a co-occurrence matrix that we have already found, this is the co-occurrence matrix, this is the final co-occurrence matrix, or C suffix D ij is a co-occurrence matrix. And from this, see, this is the co-occurrence matrix, this is normalized co-occurrence matrix, and this is the symmetric co-occurrence matrix. Okay, so we'll study how to find the different types of features. Okay, first is the energy, that is a summation, double summation for I value, j value, because you are considering ij values, and you're using a normalized co-occurrence matrix square. This is the standard formula to compute the energy. And then you have entropy. So uh, energy will provide you the intensities, or it will change your input image to the different energy level. By using this, entropy will provide you the how much the random variation you have in your image. If you want to go for high entropy, then you will saturate that region depending upon the you can say the distance between the two intensity values. You can spread out your image if you go for the entropy. Now this is the standard formula, that is negative of double summation. Now again, you're considering the normalized co-occurrence matrix, and you're taking a log, the log on your normalized co-occurrence matrix. Then you can calculate the contrast. By applying this formula, you will be able to get the difference between the input image and contrast image by applying this formula. Then you have the next feature like homogeneity. So different kind of correlation, the different kind of features you can use in order to extract the particular feature from the input image. If you use a correlation, you will be able to extract the correlated features. Correlation matrix is made up of ij. You have ij normalized co-occurrence matrix, and you have deviation I, deviation j. You have mean along the I and mean of j values. Okay, so mu I, mu j are the means, and sigma I and sigma j are the deviations of a row and column. See, if you actually see at the entropy, if you apply the formula for the input image, it has a range between your 0 to 250, and after applying the entropy, now you have the range that is from 0 to 6. Now you have, if you have the maximum pixels that are, if those are ranging in 0 to 250, means you have the maximum detail in the image. If you compare this image and this image, this is not that much detailed image, but by using the entropy, you will be able to recognize the boundaries created by the high intensity value. Boundary of each and every object has been created by the high intensity value. If this is the boundary between two different pixels, it is being created like this, white. Okay, by using entropy formula, each and every boundary, because of the entropy, you will find it shows you the pattern, the texture, or the shape and size. Okay, so if you have the example like this is a lowest entropy, this is a highest entropy, because the highest entropy will not have the ordered. No, disorder is more probable than order. So if you tossed bricks of a truck, which kind of pile of bricks would you more likely produce? Lowest, or you can say the ordered. They are arranged in ordered manner. Okay, this is disorder. This is the highest entropy, you can say this is compact entropy. Okay, this is an example of entropy. This is threshold entropy. You will find the difference between the normal entropy and threshold entropy. If you have the input image, this is the source input image. I have taken that from the paper or journal, mm, from this website. So there are different features that you can extract from the image. This is a color image, and by applying some filter or gray level, you will find the gray level image like this. Now if I want to extract the contrast, I will apply the contrast. You will find the difference between this. So suppose you are selecting this region represented by a white. After applying the contrast formula, you have the black. Okay, black will remain black, but more whiter regions are now the black in the contrast. Okay, this is the actual result of applying a contrast on the input image. If you applied correlation, you will be able to get the shape and size. Okay, means you have the boundaries for each and every shape. Okay, if you compare the correlation, you will be able to get the separation between the different fields. You won't be able to get the separation, but you can change the contrast. Okay, so each and every feature will provide you, you can use it for the different application. The application can be anything. The feature extraction can be, you can use the different types of feature extraction for a different types of application, whatever the applications are. Then you have the energy. This is the energy formula. After applying on this, you will get this video. So now this white will remain white, the black will black, this black will get white. If you have similar kind of pixel, you will be able to produce the high intensity values in the output image if you apply the energy formula on this input image. Okay. Hmm. If you have the bigger the area in a size, you will be able to create the higher intensity values, energy, high energy values. Okay, this is energy. And homogeneity for homogeneous. If you have a very homogeneous region which are showing the same properties, homogeneous nature, you can separate. You will get some difference in the output region. Okay, this is the output of applying homogeneity formula. This is homogeneity formula. You're applying the homogeneity formula on this input and you will get this. So there are different types of feature extraction that you can use in order to create a difference between your input image and the output one.